Hello, my name is Rob Reynolds. Welcome to College Algebra, section 2.4. We're going to be studying circles today. This is the general form of an equation. If it's not in general form, we're also going to be looking at this lesson, how to complete the square to get it into this general form. Here, the center is going to be h and k, and the radius is r. So be careful. Sometimes I'll give you r squared out here, and we'll need to take the square root of that to actually find the radius. So in this example, you can see the radius is 4, which means I'm going 4 units in every direction, north, east, south, and west. And the center is the opposite of this number and the opposite of this number. So the center would be 2, -1. And you can see they went 2 to the right and down 1 for the center. Here's the general, again, equation of a circle. Here's the general form, which we'll get to. If it's at the origin or the center, please don't write x minus 0 quantity squared plus y minus 0 quantity squared. We'll just reduce that or simplify that. That means that I'm at the origin. Again, general form, if I have a radius of 1, that means I'm going out north, east, south, and west 1 unit. This is also 1 unit, but that's kind of hard to plot, that point. So I would just plot 4 points and sketch the circle in as best you can. So our first example here is to write the standard form. It looks like r is given as 4, and h and k is also given. So this is kind of a simplistic type of problem. This won't all be given to you every time, but in this particular case, we're just going to plug in for h. We're going to plug in for k. Now be careful here. The k is a -4, so this says take the opposite of a -4, which will change that sign to a +4. And then I'm going to square this, and I'll, instead of writing 4 squared, I'll just clean it up to be r squared, or 16. So our final solution looks like x minus 2 quantity squared, y plus 4 quantity squared equals 16. To graph a circle, I kind of told you a little bit about it before. We'll find our center, in this case the opposite of h, and the opposite of a -2 is a +2. So I'll start at -3, 2. There's a start point, and I'll move 4 in every direction. 1, 2, 3, 4 to the right, 4 up, 4 left, and 4 down. And I'll, best I can, sketch that circle in. And this is what it will look like. This one says find the intercepts. There's plenty of intercepts here. There's some x-intercepts here in red. There are some y-intercepts here in purple. I'm just going to find some x-intercepts, and then hopefully you can finish this problem because it does take a little bit of time. But to find x-intercepts, we let y be 0. So if you let the y term be 0 right here, I'll get x plus 3 quantity squared plus -2 quantity squared equals 16. The next thing I want to do is multiply this out to solve for x. And be careful, you cannot distribute this 2. This becomes x squared plus 6x plus 9 plus 4 equals 16. 9 and 4 is 13. I'll subtract out 16 for -3. And since there are not factors of -3 that differ by 6, I have to use the quadratic formula to solve for x. So x is equal to -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Cleaning this up, -6 plus or minus the square root of, let's see, this is 36 plus 12, which is 48. And I believe 48 divides by 16, so -6 plus or minus the square root is 16. 16 times 3 is the 48. I believe cleaning this up a little bit more, -6 plus or minus 4 squared root of 3. Now be careful here, you cannot cancel part of the sum, but you can cancel both sums. So if I divide every term through by 2, I'll end up with -3 plus or minus the square root, 2 square roots of 3. Those are my x-intercepts. You would repeat this process to find the y-intercepts, but instead of letting, to find the y-intercept, you're going to have to let x be 0. And I'll spare you that. So again, we want to work on moving from, this is called the general form of the, general form is not in standard graphing form. We want to move from general form into graphing form, and the graphing form is x minus h quantity squared, y minus k. This is the graphing form that we can easily pick off the center and the radius. The center being h and k, and the radius being r. So we're going to learn how to complete the square so we can move from one form to the other. And my first example, we're going to try to move all of the x's on one side. So I'll bring over the 26x, and I'm going to create some number that will help me complete this square so I can get it in general to graphing form. I'm also going to combine the y terms. I'll do the same thing. Looks like all the y's are already on the same side, but I need to create some number so that I can also complete its square. And for this last one, this 364, I'm going to dump on the other side and make it a negative 364, but if I'll have to add two numbers on the right side as well, because I'm adding two numbers on the left side. So remember, whatever I do on the left side of the equation, I'll have to do on the right side as well. So on this side, I call this the star step. We're going to take half the middle term and square it. So to complete the square, again, I call it the star step. You take half of the middle term and square it. And the middle term comes from this ax squared plus bx plus c. So the middle term in this case is 26. So half of 26 is 13. 13 squared is 169. But if I add 169 to this side, I better add 169 to the other side. I'm going to repeat this process. I'm going to try to take half of the middle term. Half of 28 is 14. 14 squared is 196. So I'll take 196 to both sides. So the next thing I want to do is look at how to complete this square. And instead of looking for factors of 169 that add up or differ by, I just know it's half the middle term. So half of 26 is 13. And I also know that I'm just going to keep the sign. So I keep that plus sign. Likewise over here, I'm going to keep this sign right here as a plus. And half of 28, I don't need to find factors of 196 that add up. I know it's going to be half of 28, which is 14. And then I'll add this up. I think this is a 1 over here. And that's going to be in standard form. I've got my center at negative 13 and negative 14, and I have a radius of 1. And I just noticed that this should have been a y in here. So again, the general form is x plus h quantity squared, and then y minus k. And I threw an x in there, I'm so sorry. So we'll try one more example. Here we'll try this number 12. So I'm doing number 9, I'm jumping to number 12. Likewise, I'm going to throw the x's together. So it looks like they're already on the left side, so I'll keep them on the left. Let's bring all of this over as well. So I'm going to create some number to complete this square. If I bring all of this over, I have a positive y squared minus 10y, and I'll create some number. And it looks like the 97 is already on this side, so I'll add 97 plus 2 other numbers. And again, whatever number goes here, I add it to this side to stay consistent, and whatever number goes here, I add it to this side. Just because whatever I do to one side of the equation, I have to do to the other. So the star step here says take half of 6 and square it. Half of 6 is 3. 3 squared is 9. So I'm adding 9. The next thing says take half of 10 and square it. So that's 5. 5 squared is 25. Finishing up, completing the square, x minus, just keeping the sign. Half the middle term is a 3. Quantity squared plus y. Keep this sign minus. And half of 10 is 5. And set that equal to, that's 131. So if I've done this correctly, the center should be at 3, 5. And the radius is not 131, it's actually the square root of 131. So there was that first example I did, and I think we got the correct answer there. And here's the second example. If you would like to work out 10 and 11, you're welcome to see if you can work out those as well. The last little part of this video, I'm just going to show you how to graph these things really quickly. This is my, again, h and my k. So the center is negative 1, 2 with a radius of 9. So I'll go to negative 1, 2. And if I have a radius, oops, not 9, how about a radius of 3, because it's the square root of 9. So So I'll go 3 units to the right, 3 units up to the left, and 3 units down, and I'll try to sketch that circle in as best I can. Oops, looks like I missed a little bit over here. I'll do the same thing over here. Looks like the center here is -2, -3 with a radius of 2. So when all is said and done, you should get a circle with center at -2, 3, and the radius is just out 2 in every direction, north, east, south, and west. The last example is kind of a combination of everything. They are giving you an equation in general, and they want you, or the standard form, and they want you to change it to general graphing form. So let's combine this, complete the square, find the equation, and then we'll graph it. So putting everything together, plus y squared minus 6y, and I'll have a -12, throwing the 12 on the other side. And I'm going to try to complete the square here. Half of 4 is 2, 2 squared is 4. Half of 6 is 3, 3 squared is 9. This completes to x plus 2 quantity squared. This completes to y minus 3 quantity squared. Again, just keeping the sign and half the middle term. And that looks like a 1, -12 and 13. So the center must be at -2, 3 with a radius of 1, because the square root of 1 is also 1. So to graph it, -2, 3, and go out radius of 1. Small little circle. Good. That looks like a pretty good answer. So that pretty much concludes. You can graph these on the graphing calculator. It's pretty cumbersome. I'm not sure if it's worth it. I'll show you how to do it, but I don't think anybody's interested in this. To graph on a graphing calculator, you have to go to your y equals, and that means that our first step is to actually solve this for y. So solving this for y, I'm going to throw the x squared on the other side, giving me -x² plus 4. And the goal now is to take the square root, but remember, whenever you take the square root, we actually get 2 answers. So our first answer is the positive, and our second answer is the negative, or the opposite of that. Again, this gets a little bit cumbersome. Your calculator cannot actually even graph a circle because it's not a function, but it can graph each part of this function. So I'll show you. I'll type in -x² plus 4 for my y sub 1. And then y sub 2 is actually the opposite of that. Make sure you do not put parentheses around the -x, because that will square the -x, and I just want to be squaring x. I'll hit zoom 6. And it looks like it's centered at the origin with a radius of 2, which you already know. So again, kind of cumbersome to type it in, but it's possible. So if you wanted to check your solutions, your graphing calculator will actually check it. Again, some multiple choice problems. If I give this to you on a test, the first thing I would do is try to identify the radius, which is difficult to do without finding the center. So you might have to use the midpoint formula. Halfway in between 2 and 6, if I add those up, the midpoint is 8 divided by 2, which is 4. And halfway in between 4 and 4 is, again, 4, 4. So it looks like the center is 4, 4. So this one's gone because that center is -4, 4. This one's gone. So it's either between A or D, because they're the only two with the center at 4, 4. Now all I have to do is try to identify if the radius is really 2 or if the radius is really 4 out there. And remember, the definition says r squared out here. So the radius is actually 2, but the answer is going to be, that's D. Let's go, yeah, let's go for D, because that's 2 squared out there. So I think the final solution here is answer D, because they just set it equal to r and they forgot to square the r. All right, well, I hope that was helpful. If you have questions, please email me.